Okay guys, this chapter is all about heat, thermochemistry, the heat involved in chemistry. So whether or not something requires heat or releases heat or takes in heat is what we're looking at this chapter. Make sure you have your 16.1 notes out with you right now, and we're about to start filling them out. Okay guys, we're ready to start filling in our notes. So, all these reactions we've been talking about, they require us to break the bonds in the reactants and to form new bonds. Well, anytime you break something, you're requiring energy. That takes energy. Now, sometimes it releases a lot of energy, like when you guys shake up a bottle of Coke and you twist off the top, that's a lot of energy that's released into the atmosphere. So, keep that in mind. Sometimes things will take, sometimes things release energy. The study of the changes in that energy, that is considered thermochemistry. Thermochemistry. And notice I'm not saying changes in heat necessarily, I'm saying changes in energy. Okay? It's usually talking about heat, but we use the term energy. Okay? Okay, so we're talking about energy now, and we're going to be calling it heat in a lot of cases. So think of heat as a flow of energy. It's not necessarily a temperature, it's the energy as it goes into a system or out of a system. So as the heat in the classroom gets higher and higher and higher, the heat is coming from outside the classroom in. So keep that in mind. This second bullet right here, heat always flows from a region of higher temperature to lower temperature. This is known as the second law of thermodynamics. Big law, because it means that heat will always go to the cooler area. So, how do we measure this? Well, the SI unit, just like moles is for an amount of substance, we're using a term called a joule. It's a capital J, and it tells us the amount of energy or heat going into or out of a system. This is one of my favorites. It's an old Batman comic that somebody's messed with. It says, "Close the window, you're letting the cold in." Thermodynamics too, the heat goes out. So anytime somebody says you're letting the cold in, you're actually letting the heat out. It's going from the hotter room inside to the cooler air outside. Heat flows from high temperatures to low temperatures. Alright, and here we're talking about that joule unit again. It's a very tiny amount. So we tend to use kilojoules when we're talking about common things like, how many kilojoules did it require to push that box up the hill. Another unit that we use in chemistry is the calorie, the little cal, which is equal to 4.184 joules. Now guys, this is not the food calorie. The food calorie is 1,000 little calories. And that's what we call a kcal, or just the capital CAL. Calories, like what we eat every day. So what we're used to measuring is temperature, and everything changes temperature when it's heated, but how much the substance itself changes is depending on its specific heat. So a specific heat of a substance is the amount of energy required to raise the temperature of 1 gram by 1 Celsius degree. So this is really helpful because 1 Celsius could also be considered 1 Kelvin, because sometimes we're working with really high temperature stuff and we prefer Kelvin. Everything has a specific heat. You will never have to remember that specific heat. It will be given to you. Just know that the units will be joules per gram degree Celsius. Okay? Write that down somewhere. Joules per gram degree Celsius. How much energy does it take for 1 gram to change by a certain degree of Celsius? Okay guys, so let's talk about the specific heats. Now, they vary depending on what compound you're looking at. So, notice all these metals. They seem to have very low specific heats because it does not take a lot of energy to raise a piece of metal 1 degree. It doesn't take a lot because of those electrons being in the electron sea, or sea of electrons, okay? Now, notice here what happens. Water jumps double. Then ethanol, roughly the same, but look at water. Very cool, and we're going to talk about that a little more in class, so sorry if you missed that, but water does not change temperature with a given amount. It does not have a drastic change in temperature with a small change in degrees, which is a good thing. Alright, done, 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 done. It's the time now for the equation part. Now, we will be still using dimensional analysis, but right now I need you to get kind of in a equation frame of mind. We're going to be working with one equation for specific heat. How many equations? Now, pay close attention. So we're going to be using this equation. Q, which is the heat, lost or gained, is equal to mass in grams times that specific heat we were talking about times whatever temperature change you're looking at. The heat depends on the mass, the amount of temperature change you're trying to accomplish, and the specific heat. How quickly does it heat up? So we're going to start manipulating this equation. I need you to be ready, follow along with me, pause the video when you need to. Alright, so what could this problem look like? If it's a big long word problem, and you know I like to give you the scary ones, it's going to look something like this. Gallium is a solid metal at room temperature, but melts at 29.9 degrees Celsius. If you hold this metal in your hand, it melts from your body heat. It's pretty cool, right? How much heat must 2.50 grams of gallium absorb from your hand to raise its temperature from 25 degrees Celsius to 29 degrees Celsius? The specific heat of gallium is 0.372. So that's a little higher. It takes a little more energy to change it a degree, and 1 gram of it by a degree. So let's look back at our equation. Q, or heat, is equal to mass times specific heat times change in temperature. My little thing that I always did for this is Q equals MCAT. MCAT was the test I was going to have to take to get into med school. 5-hour test, by the way, terrible. But MC and the delta for change is that triangle. T is temperature. So Q equals MCAT. If that helps, use it. If you come up with something better, tell me. I love the little mnemonics. They're great. So what do we have here? I've underlined the givens. I've underlined the stuff that's important. What's 2.50 grams? Well, hopefully you know that that's the mass. So we're looking for how much heat. That's Q, so I'm going to leave that. Is equal to the mass, which is 2.50 grams. What's that change in temperature? Okay, well I'm going to have to subtract for that one. So I'm going to put it over here on the right. 29 point, and please forgive my terrible handwriting. I'm trying to do this quickly and get it posted before class. 25.0. So when I subtract, 9 minus 0 is 9. 9 minus 5 is 4, and the 2's cancel. So that temperature change is 4.9. So I've got my M. My C is 0.372. And I'm going to go ahead and put in my joules per gram degree Celsius times 4.9 degrees Celsius. Now, I didn't write this out the way I usually do. I usually put joules over grams degrees Celsius so you can really see it. So let me erase that. Yeah, it can't erase in this program. So let me just do this. So you see degrees Celsius cancels. Grams cancels, I'm left with joules, which is what heat is measured in. So when we do this math, I'm going to give you a second to pause and do the math. When you do this math, check your sig figs. How many sig figs do I need to go out to on this problem? All of these digits are given to me in three significant figures. So when you write it out, I want your answer in 3. I came up with, and tell me if I'm wrong, 4.56 joules necessary to change that gallium from 25 degrees Celsius to 29.9 degrees Celsius. And again, this is just for 2.5 grams. Okay, so it changes when you have more, when you have less. It changes when you have a higher temperature and a lower temperature. All right, absorb this. Maybe erase all that I did and see if you can solve it yourself. And we'll move on to the next one. Okay, guys, this is another way they could ask it. Now, I'm going to read the problem like I always do. I'm going to underline my numbers, and then hopefully you'll start seeing what goes where. So a chemistry student finds a shiny rock that she suspects is gold. She determines the mass of the rock to be 14.32 grams. Then she finds the temperature of the rock rises from 25 to 52 degrees Celsius when it absorbs 174 joules. Determine the specific heat of the rock. So specific heat is what I'm looking for now. If the specific heat of gold is 0.128, is the rock composed of gold? So guys, we're trying to find the specific heat of this rock. So we've got to find C in our equation. I'm going to write the equation up here. MC delta T. Now, we're going to find C and see if it matches up with that of gold. If not, it's probably fool's gold. So let's get going. My Q. What is my heat here? How much energy are we working with? Hopefully you see it's 174 joules is Q. Check. All right. M. What's my mass? Well, I've already underlined it. 14.32 grams. I've got to find C, so I'm going to stick C in the middle, which is not a great idea, but I like to keep my equations in order. And what's my delta T? Well, again, those of you who hate to subtract, get your calculator out, though it would probably do your brain some good to think. All right, 2 minus 5, can't do that, so make it 12. Knock the 5 down to a 4. 12 minus 5 is 7. 4 minus 2 is 2, 27. So my delta T is 27 degrees Celsius. Sorry for the terrible handwriting. Now, to solve this, you can do it multiple ways, but you want to get C by itself. So I'm going to divide both sides by whatever 14.32 times 27 is, and I'm not going to do that math just yet. I want to do it all at once. So watch what I'm doing here. You can go ahead and multiply and then divide it however you want to do it. Just make sure your math is good. And then I have to do the same thing to the other side. And I'm going to leave out my units just because I'm running out of space. Alright, this cancels here, this cancels here. I'm left with C. When you do your math, it should come out with the units of joules per grams degrees Celsius, which is the units of specific heat. So, do the math. I'm going to pause for a second. You pause, find your number, come back. Okay, so my answer was 0.45 joules. Okay, and I picked two significant figures because the least of all mine I had, hang on, let me switch colors so you can see this. Here I had 3, here I had 4, here I had 2. Multiplication and division, you choose the least number of sig figs, which was 2 sig figs. So I picked it as 0.45 as my answer. So think, guys, is this gold? Gold specific heat was 0.128. This is not gold. You've probably got fool's gold. So no. Answer is no. And please, please, please make sure your problems are neater than mine. Okay, guys, homework for this is homework set 16-1. Check with somebody in class. Make sure that we did all the problems before you go and spend your time doing that. As always, I've posted the answers for the first 2 on the website, so go check it out.